As we continue our tour of Google Cloud services, we've covered compute, we've covered storage or data services, and now we're in the category called Other. So this includes services such as their APIs, Translate API, Prediction API, and also network services. So here's what we're going to examine in this section. We're going to take a look at networking services, monitoring services, source code services, and some APIs that I've used with some of my customers. In this next movie, we're going to take a look at network services available on the Google Cloud. So those services include networks, external IP addresses, firewalls, routes, load balancer, cloud DNS, and VPN. A tip I'll give you from my practical experience is you want to take a look at and understand resource scopes. So you may remember from an earlier movie that project resources can be scoped globally, regionally, or in zones or to instances. And this very much comes into play with networking services. So starting from my project, let's go into networking. And let's first take a look at networks. So we get a default network that has an IP address range and a gateway and a set of firewall rules. As we add services, we will often be adjusting the firewall rules to open ports and to make services available to other services and to authenticated users. To create a new network, you just click on New Network, and then we can click Create. Now again, just to emphasize some of the common concepts when working with the Google Cloud, notice we have a REST command that we can use if we were to do this programmatically, or we have a command line, and this would be using gcloud. So we'll be heading into working with gcloud a little bit more as we progress through the course, but I want to get you used to the metaphor of pulling up the gcloud code because you'll generally start working with the console, but particularly when you get to networks, you want to often automate some of the processes that you're using, and you'll use script to do that. So click Create, and now we have our new network. Now the next thing that we can work with is external IP addresses. So we have an IP address that was set up for our WordPress instance that we created with Click to Deploy on Google Compute Engine in an earlier movie. And if we want to create a new static IP address, we can click here, and then we can call this one Next WordPress or Demo, and it can be a regional or global. So this has to do with the scope of the external static IP address. And we set it for the region, and then we can attach it to, in this case, we've got the WordPress instance, or we can just set this address up. Now, it's interesting how this is billed. Static IP addresses not attached to an instance or load balancer are billed at an hourly rate. But if we do attach it, notice it's not billed. So again, it's one of those billing implementations that people often don't encounter until they set it up. So if you have a static address and it's attached, it's not billed. But if it's just allocated, then it is billed. So let's go ahead and set this back to none. And let's change this to global scope. And again, it tells us you're going to get billed if you just reserve this without attaching it. Let's just leave it at global. Then we don't have to attach it. Say create. And notice this IP address is what's called ephemeral. So that means it can change if the instance is stopped or started. Whereas this is a static IP address, and I can change it here. Now, if I want to get rid of it, I just click inside of here, and I say release IP address. It's pretty simple dealing with this again. And again, once you do it a few times in the console, you'll generally use gcloud or a programmatic method because it's faster, particularly if you're dealing with groups of IP addresses or you're deploying infrastructure regularly or redeploying or some situation like that. So the next one is firewall rules. So again, very straightforward. We have some firewall rules here by default, and then we have one that we created when we set up our Google App Engine sample in Python. I don't know if you remember from previous movie, we wanted to test it out. So we allowed HTTP so that we could see if our sample was set up correctly. So if we want to say new firewall rule, we just click new rule, call this one new firewall, July 31st for demo, just being consistent here. Now this is associated to a network. So see, we have a new network that we created just previously in this movie. And then we can set the IP ranges or instant tags or allow from any source. That's opening up a specific port, and then we can put a specific port in here. Let's actually put an IP range, and then we would have a comma-separated IP range. allowed ports, target tags, so on and so forth. So this is pretty self-explanatory. You just fill it in and click it and you'd have a new firewall rule. So I'm just going to cancel out of that. The next one is routes. So what routes allow you to do is communicate between networks. So very similar here. So just fill in the blanks as we've done. So new route, you associate it to a network. You put the destination IP. Again, if you don't know what these things are, you can just click on the question mark. So it's a similar interface. You set the priority. Okay, this might be a new thing for us. Priority is used to break ties when there's a contention. And so the priority values are just a numeric value that you can put in. And now it's giving me an error because it says you have to have a priority once you mess around with that dialog box. I'm going to tab out of that. And then instance tags. And then you can say the next hop is a particular instance or an IP address. So it's, again, pretty straightforward in terms of setting up routing. The next thing that you can do with networking is load balancing. So for network load balancing, again, pretty self-explanatory. Load balancing distributes traffic across healthy VM instances, and you'd probably be using VM health checks here, and they could be different zones within a region. It enables your application to support heavy traffic and avoid failures. This basic setup is going to create a single forwarding rule, a target pool, and a health check. So health checks are, as I said, a normal part of load balancing on the Google Cloud. For complex configurations, you want to use these other subsequent options here. So you're going to have a common region and name prefix, and then you're going to set up your forwarding rule. And if you want to change that, you can adjust that if you want to. And then you can set your external IP to an ephemeral IP or a static IP address. And we just saw how to do that. You can set your port, and then you can create your pools. Now what pools do, as it says, it distributes traffic among healthy VM instances. So you can create a new target pool and you add instances, and there's our WordPress that we set up in an earlier movie. Or you can use an existing target pool if somebody else has created one and made it available to you. You also have the ability to set session affinity. So what that does is it creates sticky sessions. So that means when you are having communication between nodes or instances, they will continue to communicate to that same physical location. That's what session affinity is. And then here's the health check. So health checks use HTTP requests to determine if a VM is healthy. So if you wanted to create a new health check, you can give it a name, and then it goes default on port 80, which you can change, and then you set an interval if you want to. You could change the port, or you could change the timing, for example. So if we wanted to create this, let's see if there's anything else here, we can just say create. All right, so now we have a network load balancer in our project for all of our services in our region, US Central 1. And this is what I was talking about with the scope. We have regions in the Google Cloud. So we have US, we have Europe, and we have Asia. We also can do HTTP load balancing. And it tells you here it sends requests to different backend services based on URL patterns. It's a similar type of process to set up, but again, we're using HTTP rather than internal network. So I'm not going to take the time to show this in this demo, but if you need that sort of service, you just follow the similar pattern going through the GUI here. The next service is Cloud DNS, and then we would have to create a zone and then create records within that zone. And the next service we have is VPN. I use this more commonly than something like a Cloud DNS, so I'll take a little bit longer to go through this. So a VPN is a secured set of resources within your cloud project. So as it says, whether your data center is on-prem or co-located, securely interconnect it with Google Cloud Platform using Google's site-to-site IPsec VPN solution. So you would make your VPN, you'd put in a description, and then we can create a tunnel. So for this, we need a remote peer IP address. So again, I can't fill this in because I'm not connecting to an actual network here locally, but you'd put your network's VPN gateway. And then the IKE version, the Internet Key Exchange, supports IKE v1 or IKE v2, the shared secret, the remote network IP range, and then you would create it. So this is something that I have had to set up for some of my customers, and some people were actually surprised the service was available, so I wanted to make sure and include it. I'm going to, once again, just show you the command line. It won't be completed, but you can see it's a series of G-Cloud commands. And this is a prelude to the next section that we're going into, where we're going to be working more extensively with tools that aren't on the console. Google Cloud offers services around management and monitoring of your solutions. They include traces, logs, dashboards, and alerts. We're going to take a look at monitoring. Now, by default, you'll see if I clicked on the monitoring section, I have for my project, App Engine, Compute Engine, and other services that I've turned on. So it's a top-level view. Now, if I want to drill in, the first thing that I'm going to see is traces. By default, traces are disabled for this project. So we're going to enable traces, and it gives me a little movie that talks about CloudTrace being a free service that helps me to debug performance issues and gain insight into application latency. I can watch the video or I can see the documentation. And I haven't created any traces yet. I would need to filter by entering the first part of a URI in order to get trace information. I could then create custom reports, and they're giving me a video again to work with here. If I click Create Report, everything is URI based. So I need the address to the resource, and then I need the type of call and the module. So I can have all modules or default modules. I can have all versions or a particular version. So this is when I want to capture a subset of information. And probably would make more sense to look at the logs, because the logs capture all the information, and the logging is turned on by default for many services. So this can help you to get an idea of what information is even available without watching any of the videos. So I'm going to dismiss this, and you can see for App Engine default module, I've got some logging going on here, and I can look at different types of logging. If I want to drill in, I can see the details, and I have a lot of different filters. I can also filter by label or text search. Now, if I want to switch this to Compute Engine, I'm going to get different kinds of logs. Now, if I want to just look at logs of a certain type, I can do that. I can see if there are any warning logs. There shouldn't be, because this is the default implementation. And then here's my info logs. And once again, I can easily drill in. Now, I have found, particularly when I'm working with App Engine, that the use of the logs can really help me to figure out if there are errors or if there is code that's written in an inefficient way that's causing excessive computation or causing excessive calls to the underlying data sources. So I've used these logs quite extensively. If you click on Exports, you can see that the logs can be exported by service, and they can be exported to BigQuery, kind of interestingly, for analysis, or Google Cloud Storage, or to PubSub, so you can get notifications when certain activities occur. So it's a nice integration with other cloud services. This is not something I've used other than putting the logs out to BigQuery. I have done that, but I haven't used PubSub at this time. It seems like an interesting capability, particularly as I start to work with more IoT projects that are going to generate very, very unpredictable spiky loads. I would want to be notified of certain types of events, maybe device crashing or running out of information or device not updated, that kind of stuff. So I can really see a use for this going forward in some of the work that I've been doing with cloud solutions. Now, in addition to this, I have dashboards and alerts, and this is powered by Stackdriver, and it's beta. So what you can do, as it says, is look at the whole stack. So we're going to enable monitoring, turn this on. And while this is spinning up, notice the service account can be managed from the permissions page. And you'll remember from an earlier movie that the accounts that are used to run the various services should be non-admin accounts. So you should be making additional accounts. All right, so now this is turned on. So I would need to create alerting policies, monitor endpoints, and then I can see some other information. So if I go to monitoring, that's going to take me to a separate console. You can see I'm automatically logged in, and I can also get these reports in email. So I can monitor uptime, set alert policies, create dashboards, a lot of extensive monitoring. So I will leave it to your particular situation to work with the monitoring types, but be aware that it's relatively quick and easy to set up these dashboards. And I do end up working with my customers to get these set up when we move into production in particular. Now, the next section that I want to take a look at while we're inside of monitoring is called source code. So source code is the ability to get a free, private, Git-hosted repository location. So why you might want this is you might want to work with your code, particularly App Engine code is an example of something I've done with this, while you're inside of your project. So as it says here, you can jump from a log, where we just were, to the exact line in the source code. So it's really a new way of working rather than working, for example, in a local, let's say, Eclipse Java editor and debugging and running locally. You're actually running live on the cloud. Now, there's a lot of strong opinion about this. Certain companies that I've worked with, absolutely, this does not work with the way that they work, and they have structured processes for releasing code up into the cloud or any production situation, and they would not want to enable debugging in the cloud. Other companies, more often startups, are really excited about this because it speeds up their processes, and that's what it really comes down to being all about in the world of some enterprises and startups. So I'll show you what this looks like. And you can see that the cloud repository is empty, and we could automatically mirror from GitHub or Bitbucket. We could push code from a local Git repository, or we could clone our code repository to a Git repository. So if we wanted to mirror from GitHub or Bitbucket, we would have to sign in. So once we have code up in this location, then what we're able to do through debug is we can actually work in that repository, and we can run that code and set breakpoints, and we can debug live in the cloud. Again, the use case I've had for this has been with a couple of startups that really wanted to just work in one interface and be able to quickly and easily see where bottlenecks were occurring in their code. So this is a specialized set of services, but I've been surprised to see how many customers actually are trying it out and liking it. As we continue looking at other services, we're now going to look at some of the APIs that are available to the Google Cloud, but not considered Google Cloud services. One is called the Prediction API, and this is a type of machine learning or data mining that is available. It allows you to do non-deterministic data mining type queries on data. And so I've used this with some of my customers, and I wanted to show it to you. We want to go to APIs, and then we just want to type prediction, and we'll see the Prediction API. And as it says, you can make, as they call it, smart applications that respond to streams of data by providing quick and easy access to machine learning algorithms. Now, you're not getting access to all of Google's machine learning algorithms, and this is an area of active development. So this is something that if you're interested in machine learning support on the Google Cloud, you want to watch for announcements, because the core services use extensive and different types of machine learning. And this is really just a subset, but it's usable, and I've used it with many customers. So I'll show you how it works. So as with the API that I showed you for cloud storage in an earlier movie, this does not show up in the main console at all. So first of all, we have to make sure that the API is enabled. And strangely, it's enabled by default, but it doesn't show up. So you just have to go to this spot for Prediction API, and then you can explore the API using the API Explorer. And this is similar to what we saw with the advanced cloud storage capabilities. What you're looking at here are your API calls. So you've got prediction and then dot, which allows you to access one of the objects and basically the nouns. And then you have dot, which is the method or the verb. So the key aspects of working with this are to predict using either a hosted model or a trained model. Now, we won't have any models because I haven't set this up yet, but just going through to show you what this looks like. Of course, as we did with the previous API, we need to turn on OAuth, which is going to ask us to be able to work with information of these scopes. And we're going to authorize this and say accept. And so if we had a list of models, which we don't, we would have the data associated with the project. So again, going back to our project and putting in the project ID, we would expect a null result here. And then we would have their optional parameters, and we would have our fields editor where we could select, in this case, models of a certain type or a certain name. Let me turn my OAuth on and execute. So now you can see that we got an OK, but we have no models inside of our project. Now, in order to create these models, we would have to programmatically access the API. There's no G-Cloud, there's no console. You have to use the programming language, so Python, Java, Go, and then you would have to call these methods, passing in the appropriate parameters to set up models and then to call predict against them. So you would be working with the documentation. But I do find this API Explorer is a great way to iterate back and forth. It's an alternative console, if you will. So if we go back to the projects and we refresh, you'll see at this point, there's nothing under data or storage. So it's a good practice to go over to APIs and work with the different APIs that you've turned on and not assume that they'll be inside of the console as well. So another API that I've worked with is the Genomics API. So this is very much a specialty API that's designed to process genomic data, which has formats that are specific to the industry more efficiently than some standardized data formats. So this is similar in how you access it to the previous APIs that we've looked at. I'm going to start from my project, go to APIs. I'm going to type the beginning of genomics. And as I said, it's for uploading, processing, querying, and searching genomic data in the cloud. I'm going to enable the API. And one aspect of working with this is the actual usage and the quotas. Now, in some of the biomedical companies that I've worked with, we've needed to raise the quotas. You can apply here, but we often find we need to speak to someone at Google to get the appropriate quota amount for testing and POCs. So let me go back to the overview, and you'll know now that this little square takes us out to the API Explorer, and we'll need to authorize requests using OAuth. We'll need to set the scopes that are authorized, and for demonstration, I'll just authorize all of them, and we'll accept. And now we can work with genomic annotation sets. So in some ways, this is similar conceptually to the prediction API because you have sets of data and then you work within those sets of data. Again, there are specifics to the data in this industry that are associated as part of this API. And if we were to work with this, very familiar, hopefully now looking at API usage in the API Explorer from this and other movies, if we wanted to, for example, look at the list of annotation sets associated with the project, we would have to get an annotation set ID, and this is a required field. And then we could optionally specify information about this, so a source URI, a type, so on and so forth. And then once we filled in these values and clicked execute, this would make an HTTP request and return the result. Now, in addition to working with the API Explorer, most commonly you are going to be programmatically accessing the data, so you are going to work with the underlying API as well. Now, notice, and this is a common situation with some of the APIs, that there are different standards in terms of the data, so you want to make sure that you're working with the version of the API that conforms to the underlying data when it's particular to the industry. I've encountered this in biomedical, manufacturing, education, government. So this is actually rather common in the realm of big data. As standards emerge by industry, cloud providers, including Google, will attempt to support those standards and to create APIs which make working with this specialty data easier. So with the genomic data is just one example of this, and I'm seeing this as a trend working with specialty data in the realm of big data on the cloud.